What is the role of material properties and environment in design flaw failures? Imagine a tiny crack in a metal part causing a huge machine to break down unexpectedly. Sometimes, failures happen because of how materials behave or the environment they are in. When designing products or structures, understanding how materials respond to different conditions is key. Each material has specific traits like strength, flexibility, and resistance to wear. If a material is not strong enough for the load it carries, it can crack or deform under stress. For example, a thin metal wire might snap if it is not thick enough to handle the tension applied to it. Fatigue is another common failure mode. Repeated stress over time weakens materials, even if each load is small. If a design has sharp corners or stress risers, cracks can start there and grow with each cycle. This is why smooth, rounded edges are often used to prevent crack initiation. Creep is a slow deformation that happens when materials are under constant stress at high temperatures. If a component is exposed to heat over many years, it can stretch or thin out, eventually failing. Environmental factors also play a big role. Exposure to chemicals, moisture, or salt can cause corrosion or rust in metals. When metals corrode, they lose strength and become more prone to breaking. Polymers or plastics can crack or degrade when in contact with certain chemicals or when exposed to UV light from the sun. Temperature extremes can change how materials behave. Metals may become brittle in cold weather or lose their strength in high heat. Mechanical environments like vibrations or shocks can worsen weaknesses. For example, a part that already has a tiny flaw can fail faster if it is subjected to constant vibrations. When designing, it is important to match the material's properties with the environment it will face. If a component is meant to work in a salty, humid environment, choosing corrosion-resistant materials is essential. Also, designing with smooth transitions and proper thickness helps distribute stress evenly and prevent stress concentrations. Protective coatings or treatments can shield materials from environmental damage. Testing products under simulated conditions helps identify potential failures early. For instance, testing a bridge component in high humidity and temperature cycles can reveal if it might crack or corrode over time. When material properties and environmental factors are ignored or mismatched, failures are more likely. Cracks, deformation, corrosion, or sudden fractures can happen because the design did not account for how materials respond to their surroundings. In essence, understanding how materials behave and how the environment influences them helps prevent failures. Proper selection, thoughtful design, and testing are the best tools to avoid these issues. When these factors are overlooked, small problems can turn into big failures, costing time, money, and safety.